energy. Okay, so I'm just going to do all of them over again. If you already know this part, then you can go ahead and feel free to skip it. Okay, so how much energy in kilojoules does a 75 watt light bulb use when it is turned on for 25 minutes? So I always like to start with what I know, 75 watts, and I need to end up with kilojoules of energy. So I always kind of remind myself to make sure that's the unit I end up with by the time I'm done, kind of a little check. So how do I go from watts to kilojoules? So what do I have for conversion factors? Well, I know that 1 watt is 1 joule per second, and that's really helpful to get me to the joules situation, and then I can just change my joules to kilojoules. Alright, so that's my plan. So I also know that 75 watts is equal to, if 1 watt is 1 joule, then I know that 75 watts is 75 joules per second. So I'm just going to start with 75 joules per second. And it's turned on for 25 minutes. Well, that's minutes and this is seconds. So I have to get over to minutes to figure out what's going on. So I also know that there are 60 seconds per minute. And I know that the light was on for 25 minutes. So I'm going to put the 25 on top so my minutes cancel out. Sorry. And then I have to know my metric because this is joules and they want kilojoules. So I also need to know there's 1,000 joules per kilojoule. And this is all going to get multiplied or divided depending if it's on top or bottom. So you can write it with these X's, or you can do it the chemistry way and kind of make it dimensional analysis. I kind of prefer this way. It just helps my eyes to organize what's going on. And then I like to make sure I'm going to end up with the right unit. So this second is going to cancel out with that second. These minutes are canceling, and these joules are canceling. So I'm left with kilojoules, which is what the problem wants. So I know I set my numbers up correctly. So then I just put this into a calculator, and I'll go 75 times 60 times 25 parentheses divided by 1,000, and that should come out to 112.5, and remember to label kilojoules. Box it, and that's how you get your point. So on this FRQ you get 1 point for setup and 1 point for answer with units. The next one gives us a little setup information. A kilowatt unit is a unit of power, and the hour is a unit of time. So a kilowatt hour is 1 kilowatt delivered for a whole entire hour, which is also 36 seconds. Okay, so now we're going to assume our electric bill gives us 1,355 kilowatt hours over a month's period of time. Find the energy used in kilojoules for that day. So for part A, we are given 1,355 kilowatt hours, and we need to know how many kilojoules happened in the month. So how many kilowatts to kilojoules? Well, it's telling us right here, 1 kilowatt hour is 3,600 kilojoules. So that's easy. 3,600 kilojoules per kilowatt hour. My kilowatt hours cancel, and then I can just plug that into the calculator real quick. It's a fast multiplication problem. Sorry, I pre-did it so I could save time, and now I lost it. 4878000. 4878000 kilojoules. Or, if you're a scientific notation, 4 point, you can round up, 9 times 10 to the 6th kilojoules. Either one. Box it, label it. So you get 1 point for setup and 1 point for the answer. B, find the energy used in kilojoules for the 30-day period. Oh wait, ooh, that's a ding dong. Find the energy used in joules per days. So my answer's in kilojoules per month, and now I gotta switch that to kilojoules per day. But I still need this answer to help me get there. So I've got my 4878000 kilojoules. And now I need to know how many per days. And this was kilojoules per month. And I want joules per day. So I can start out changing my month or my kilojoules. It doesn't matter. But I know that 1 month is 30 days. And I know that I want my days on the bottom because it's going to be kilojoules per day. So this per days is telling me that the days better be on the bottom, which I have it here. So that helps me know I'm doing it right. And then I need to know joules on top. Well, I know that there's 1,000 joules per kilojoule. That puts my joules on top. My months cancel. My kilojoules cancel. I'm left with joules per day, which is what they wanted. So I know I set my numbers up the right way. Now I put it in my calculator, and I'm going to get 4878000 times 1,000, so some more 0000s, and divide that by 30. And that is going to give me a really big number. 1.626 times 10 to the 8. 1.6 times 10 to the 8 joules per day. Now, if I just put joules, I'd get it wrong because it's joules per day. So units are important. And then the last part is how much are they going to charge us for that? So now we have money. We're going to get charged 7.5 cents almost per kilowatt hour. And I know how many kilowatts did I use? Well, that was in my original question up here. So I just need to use that to cancel it out. 1355 kilowatt hours. Those units cancel. And that's going to give me some money. And that's going to tell me I spent $101.49. So for money, you got to go all the way out to the hundredths for the pennies. Perfect. And that's reasonable. Around $100 a month is reasonable for a house's electric bill. If you got like a million or 1,000, that's a problem. That's not normal. So again, check your electric bill at home and see what normal looks like so you have a sense of it. And you can be like, that seems unreasonable. Or, that sounds about right. Okay. I hate when I already did it. I was going to erase them and I did not. Don't look yet. Shh. Don't look. Okay. Dang it. I did that to second period already. I have to do it again. Okay, so here we go. Just pretend that didn't happen. Okay, so we've got a 100-watt light bulb that's 20% efficient, and how much energy is it going to use in 12 hours of operating it? Okay, so we need to go from what we know to what we need to know. So we have 100 watts, and we already know it's 100 joules per second. So if it's okay with you, I'm just going to start with this, because that's just a quick little switch over. So I have 100 joules per second. How much energy is it using in 12 hours of operation? I've got seconds, and I need hours. So I know, let's see, that there are 3,600 seconds in an hour. And I know that this light has been on for 12 hours because it told me right here in the problem. So I can cancel out my seconds and my hours, and that will give me joules. And it doesn't say how much energy in joules, so I can just assume that's going to be okay. The AP exam will tell you answer in whatever unit, so it'll be much more specific. I multiply all of these numbers together, and I get 4,320,000 joules. All good. All right, so part B, how much energy does the bulb convert to light in 12 hours? So we know that it's 20% efficient. So I can take answer A for 320 joules, and I can do divided by 20, or I can do 4320000 and multiply by 0.20. It's the same thing. And that comes out to be 864,000 joules of light, because now we're doing a specific type of energy there. And so we could subtract this from this and say the rest is heat energy. They could ask you to do that. What? All right. Part C, convert the total energy, so that's A, keep track of what's happening, to kilowatt hours. So now all that's asking us to do is convert joules to kilowatt hours. So take what I know, 4320000 joules. And how do I go from joules to kilowatt hours? Well, this seems pretty handy. Here's kilojoules and here's kilowatt hours. So if I do 1,000 joules to a kilojoule, and then I know that there are 3,600 kilojoules per kilowatt hour using this conversion right here. So my joules cancel, my kilojoules cancel. I'm left with kilowatt hours, which is what they wanted. Oops, darn it. I put that in the calculator. And I do 43200 divided by parentheses 1,000 times 3,600 equals, and I should get 1.2 kilowatt hours. All right, an electric clothing dryer has a power rating of 4,000 watts. Oops. Assume a family does 5 loads of family each week for 4 weeks, and assume a dryer load takes an hour. Find out how much energy in joules and kilowatt hours is going on. Okay, so for A, we need to think about what we know and what we need to know. So find the energy used in joules. So we know it's using 4,000 watts, and we already know that's going to be equal to 4,000 joules per second. That's equal. We learned that from up above, right? Way up here, right here. 1 watt is 1 joule per second, so 4,000 watts is going to be 4,000 joules per second. Okay, so because we know that, we're going to take our 4,000 joules per second, and we need to find out the energy used, let's just start with joules, for this whole time. So we need to do some other figuring. The family's going to do 5 loads of laundry each week for 4 weeks. So that's 5 loads of laundry for a week for 4 weeks. So we got to go 5 times 4. So that's going to be 20 loads of laundry for the month, per month. So we need to kind of keep track of what's happening. And then each dryer load takes 1 hour. Probably have to know that later. Actually got to know that now. So how many hours are we operating this thing for? So we need to know all that information. Sorry. Okay, so I've got 4,000 joules per second. I also have 1 hour per load of laundry. I also have 5 loads of laundry per week. See how I'm setting this up to cancel? And then I know it's going to go for 4 weeks. And then I also know it's going, sorry, I lost my thought. Oh, for the hour. But this is in seconds. So I know it's also 3,600 seconds per hour. Okay. So now I have gotten seconds are gone, the loads are gone, the weeks are gone, and the hours are gone. So now I've got joules, which is this one. So if I put all that in my calculator, it's all multiplying, it's all on the top, right? That comes out to 288 million joules just to have clean clothes. 288,000,000 joules. But it also wants us to figure kilowatt hours. So now I gotta convert this to kilowatt hours. So now I'm gonna go 288 million. And how do I go to kilowatt hours? I forgot. What do I do? Oh my gosh. How does that work? Well, it's not that hard. Remember, it's 1 kilowatt hour is 3600 kilojoules. But this is in joules. Oh, maybe that's too much of a jump for you guys. Hold on 1 second. Sorry. I was doing my silly jump ahead math. Let's go to kilojoules. So I know there's 1,000 joules per kilojoule. And I also know there's 3,600 joules per second, right? I think that's right. Sorry. That seems weird. 288 million joules. 1,000 joules per kilojoule. Wait, it's my equivalency up here. Yeah, 3,600 kilojoules per kilowatt hour. Or I could do 36. Like that, and that'd be joules per kilowatt hour. I could skip it. What? Okay. It's okay, it's okay. So I have 1,000 joules per kilojoule, and I need 3,600 kilojoules per kilowatt hour. So 3,600 kilojoules per kilowatt hour. And that is going to turn out to be 80 kilowatt hours. Okay. So part B now wants to know how much is it going to cost to do this for 4 weeks at this rate. So we take our rate, what they're charging us, which is a little over 7.5 cents per kilowatt hour, but we know it's only 80 kilowatt hours, right? So we can cross off our kilowatt hours to give us our money. And then we know it's going to cost us about $6.06 per month. So it's like all this energy, it's only $6. All right. So is it cheaper to go to a laundromat, or is it cheaper to do it at home? All right, let's look at this refrigerating one. Okay, so refrigeration's costly. A single door manual defrost refrigerator uses 600 kilowatt hours per year, and a large one uses 20, a two-door, uses 1880 kilowatt hours per year. How many kilocalories per year for each refrigerator? Kilocalories? What? Oh, they're going to give us a conversion. So they're just seeing if we could do math. That's all this is. Okay. So let's start with the single door. So let's label what we're doing so the grader knows what's happening. So our single door refrigerator, it uses 600 kilowatt hours per year. And remember, we want to get to kcals. So how do we convert it? Well, it's not that hard because we have the conversion right here. So all we gotta do is cancel this out. So 1 kilowatt hour is 860 kilocalories. So we just multiply those two numbers together, easy peasy, and that's 516,000 kilocalories, because these cancel out, per year. Now let's do the double door. Well, it uses 1880 kilowatt hours per year. And how many kilocalories is that per year? Same number factor, 860 kilocalories. And we do that math. Oh, sorry, per kilowatt hour. Getting sloppy. Multiply those two numbers and it's 1,616,800 kilocalories per year. So that's not bad. That's just, can you flip math around? Okay, assume you can use an air conditioner for 137 days, 24 hours a day at a rate of 7.25 kilowatts per hour. Assume the cost is 8 cents and 1 kilowatt hour is 3,400 BTUs. Man, they want us to do so much stuff. What a bunch of jerks. All right, calculate the total number of kilowatt hours used per year. Okay, so what do I have to work with? I want to end in kilowatt hours. Well, I know how long I'm doing it, so I'm going to start with how long I'm operating this. So 137 days. And per year. And I know I'm doing it 24 it's 24 hours per day. That'll cancel out my days. And then I also know I'm using 7.25 kilowatt hours per hour. Okay, and my answer should be kilowatt hours per year. And if I look here, I cross out my days and I cross out my hours, so I have kilowatt hours per year. Perfect. That's all I need. So sometimes it can just be you don't know what to do and you can just set up your numbers to cancel the units out and then it's all gonna work itself out like magic. Magic witches. Okay, so if we put those numbers in, it's 23,838. 23,838 kilowatt hours per year. All right, so how much does it cost to run this guy for a year? Well, we know how many kilowatt hours it is, and we know the price right there. So let's just multiply those two things. So we can do 0.0825 per and times it by 23838. Oh, this is per kilowatt hour. Sorry, I jumped in my brain. 23838 kilowatt hours per year. My kilowatt hours cancel. I get some money, and it should be 1966 and 64 cents per year. All right then, how many kilocalories are we using per year? All right, well, we know how many kilowatt hours, so we'll take 23 from problem 1. Remember, they love to use that. Previous answer, kilowatt hours per year. And then how can we get to kilocalories? Well, we know from up above, there's 860 kilocalories per kilowatt hour. So those are going to cancel. And we're going to get this multiplied together is 20,500,680 kilocalories. Wow, what if those were the eating kinds of kilocalories? 20 million calories. I don't even know how big it'd be. Okay. And then just to be a show-off fancy math person, how many BTUs do we use in a year? So we're going to take our same A number, 23,838 kilowatt hours per year. And now we need to find a conversion for BTUs. And so way at the top of our paper, it gives us a conversion factor over here. and a BTU equivalent. Blah blah. That's not the one I want. Where is it? Oh, it's right here. I was looking for the 3400. I didn't even see it. My bad. Okay. So we know that there is 3400 BTUs per kilowatt hour. So that's a simple one. Just multiply those two numbers together. And we got 81,049,200 BTUs per year. Ta-da! So literally it's just looking for the conversion factor, cancel out the units it can cancel, and make sure you're left with the units that the question is asking for. All right, so our next one is about our lights. Okay, our lights. So we use 400 watts per hour, an average 4 hours a day, every day for a year. So remember, when we see these watts, we can remember that is the same thing as 400 joules per second. How many kilowatt hours does this represent? Okay, so I'm going to go 400 joules per second. And I know, sorry, that was a bad line. I know that there are 3,600 seconds per hour. I know these lights are on for 4 hours. 4 hours per day from the problem. I know that there are 365 days in a year. You should know that. I hope that's not like that we're doing it every day for a year. That's why we had to put that in there. Okay, so far, I like to kind of check where I'm at. I got my seconds gone. I got my hours gone. I got my days gone. I'm at joules per year, and I need kilowatt hours per year. So I need to get from joules to kilowatt hours. So I know that there are 1,000 joules per kilojoule, and I know there are 3,600 kilojoules per kilowatt hour. Why do I know that? From all the stuff up above on the top of our page. So that was a conversion factor we knew about. Okay, maybe it wasn't the top. Right here. This one. 1 kilowatt hour is 3,600 kilojoules. So I had to manipulate my joules to kilojoules and then my kilojoules to kilowatt hours to get to the right answer. So if I stick all of that into my calculator, it should come out to 584 kilowatt hours per year. 584 kilowatt hours per year. Okay, and then part B says, hey, what if we replace the lights with a fluorescent bulb that saves 60 watts a night? What is our savings in kilowatt hours? So pretty much we're doing the same thing, but we're going to use this 60 watt number instead of this 400 watt number. So that's not so bad. We can just subtract. Here's a tricky way to do it. Just subtract this, right? So 60 from 400, it's going to be using 360 watts or 360 joules per second. So some common mistakes is kids will just put 60 in, or you'll not like realize we're saving 60 watts out of the 400 watts. So you have to do 400 minus 60 to give you that, sorry, 340. I put 360 up here, 340. So pay attention. That's just a little trick they like to do to see if you're paying attention. But it's the exact same problem except with this 340 joules per second. I'm going to get sloppy because I'm out of control. So 3,600 seconds per hour, 4 hours per day, 365 days in a year. We're not doing leap year. gives us 1,000 joules per kilojoules, and a kilowatt hour is 3,600 kilojoules. And if you put all that in, you should come out with 496.4 kilowatt hours per year. But it's asking you what is the saving. So you're saving the subtraction, right? This is how much it's using. So you subtract these two numbers to find out what the savings is going to be. All right, and then C, if the fluorescent bulb is $18 but lasts for 10 years, is it a good investment? So how do we know if that's a good investment? Well, if you take the price, 0.08, we're just taking it from the other problem, 0.0825 dollars per kilowatt hour. And then we subtract that 584 minus the 496.4. That gives us sorry, I didn't do it on my calculator. 584, let me do it real quick. 584 minus 496.4, that's 87.6. So I'll put that 87.6 here, and that should give me times 0.0825, about $7.23. And that number is telling me how much I paid for the bulb. So if the bulb costs $18, I can pay that off in like 2.5 years, less than 3 years, and the bulb lasts for 10 years. So is it worth it? Yeah. Paid for in less than 3 years. So it's probably worth. There you go. Nice. Okay, transportation. I think this is getting down to the end. Yeah, it's our last one. Okay, so transportation costs a lot. So now we're going to talk about putting some gas in your car. So calculate the gallons of gas used just to go to the supermarket in 1 year if you take 5 trips per week. Why would you do that? Going 7.5 miles round trip, and your car gets 22 miles to the gallon. Okay, so what do we know? So we're going to take 5 trips per week, and we are going to go 7.5 miles per trip. That gets rid of my trips. And our car gets 22 miles per gallon. And we're going to do this 52 weeks in a year, because we're doing it for a year. So keep track. We got rid of trips. We got rid of our miles. We got rid of our weeks. And that's going to tell us gallons per year. And this is the count gallons in a year. So that's what it wanted. Sweet. So if we put all that in, math that out, it should come to 88.64 gallons per year just to get your food. Important safety tip. Go weekly to groceries or bi-weekly to groceries. You save a lot, right? Don't go every day. Okay. Now, convert your gallons to kilocalories per year if there's 32. That's easy. So we take our gallons, 88.64 gallons per year. But we know that there are 32,000 kilocalories per gallon. Gallons cancel. Multiply those two numbers. And we get a big number, 2,836,363. 2,836,363. 363.64 kilocalories per year. Okay, now C is a write it out kind of a thing. So what are some other energy associated uses associated with getting the food to the consumer other than transportation costs? Well, we have to grow the food, we have to process the food, we got to package the food, and all of those are going to take different kinds of energy to happen. And maybe we got to care for the livestock. So there's a whole bunch of like stuff you could write about. It's like an FRQ-ish kind of a question. So D, what suggestions should the average American do to help save energy and money? So the big thing is eat less meat and buy local, because then you don't have to transport it as far and use all that energy. Alrighty, so hopefully that helped you. And I think we did it! Hooray! Okay, so let me know if you have any questions. Otherwise, I really hope this was helpful for you.